Hello, everyone. My co-presenter and I are really excited to be speaking at this year's GopherCon. We're newbie presenters, so please be kind to us. Our talk, titled Best Friends Forever, BFFs, Lambda, and GoApps, is an exploration of serverless at AWS, as well as a presentation of serverless fundamentals in general. We are really passionate about serverless. We use it every day, so we're super excited to bring it to everyone at GopherCon this year. First, let's start with some introductions. Xiao, would you like to introduce yourself first?
Sure, thank you, Adelina. Hi, everyone. My name is Xiao Liu. I'm tech lead at Cytora. We focus on boosting underwriting productivity with data and machine learning for insurance companies. If you'd like to learn more about us, please feel free to reach out.
And I'm Adelina. I'm a senior software engineer at Cytora and Xiao's colleague and headache. I've been working with Go for 3 years now and for serverless for 10 months, which is how long I've been at Cytora for. So we have a lot of ground to cover. And let's have a look at what we're going to be doing today. First, we're super excited that we've built a demo app for you using serverless, and we will show you what it does. It's titled Gopher Tweets, and it's for gophers to tweet. See what we did there? Then we will go into Serverless 101 to talk about the fundamentals of serverless. Since this talk is aimed at anyone that's like a serverless newbie or anyone that's curious about serverless, we want to start slowly and introduce all the fundamentals to you before we go really into the nitty-gritty. We will have a section about serverless in action where we talk a little bit more about the details of AWS. As Xiao mentioned, we use AWS. So this is what we know and what we want to present to you. Then we will exit the whole, the whole slides, the whole presentation mode, and we will go to a live demo where we will change the code that we've made, and we will show you how to deploy and run serverless apps. And we will do a very lightweight roundup just to give everyone as much time as possible to ask us questions if you wanted to. So without further ado, let's introduce Gopher Tweets. When you're at a conference, there's so many new things, you're learning all the time, you're attending lots of talks, so it can be really difficult to remember the name of the talk that you attended, the handle of the speaker, what conference to tag, what tags you want to add, and this is like can be really overwhelming. So this is what Gopher Tweets can do for you. We pre-construct a tweet body that tags a speaker that you selected, tags the name of the talk that he or she has presented, and tags the conference so we can all feel like we're a part of a community despite the fact that we are remote. And most importantly, Gopher Tweets is our serverless use case. It allows us to learn about serverless while making it easy to tweet about GopherCon. So the app is already ready for your tweeting pleasure, and it will continue working for the entirety of GopherCon. You can find it at tinyurl.com/gophertweets. Now, Gopher Tweets posts tweets on your behalf, so it authenticates with Twitter using your personal credentials and uses issued tokens to post constructed tweets on your behalf. We don't store the tokens in Gopher Tweets in any way, so please don't worry about any kind of security problems. So as I previously mentioned, the URL is tinyurl Gopher Tweets. So I will first sign into Twitter, and we need to allow authorized Gopher Tweets access to our account. So I'll click authorize. This brings me to the logged in screen that you saw before. All the speakers that have opted in for the speaker spotlights are on this list, and we have taken their photos from the GopherCon Twitter account. So I'm going to tag myself, to choose myself, and tweet about the talk. And I'm going to say, this talk is happening now. So you can see exactly what you're tweeting. You can change it, but all the tags are there for you to use without having to worry about remembering them. Then finally, I will post the tweet, and the tweet is posted successfully. Now, You don't have to take my word for it. I'm going to go to my own Twitter account, which is the one that I tweeted with, and I am going to reload it. And there goes the tweet that I just posted. This talk is happening now. So production is working. That's great for us. If you want to go back and go for tweet again, you can just select a different speaker and then tweet about them. So now that I've completely blown you away with this demo, it's time to go back to our presentation and have a look at really the learning that we will look at today about Serverless 101. So what happened to the servers? What does serverless really mean? Fundamentally, serverless code is code that is run without you, the application developer, having to manage your servers. The code that you run, the code that you write is run in functions, which are stateless execution environments that only live while they're being called. The third-party provider takes care of managing, scaling, and monitoring these execution environment or containers. The third-party provider does all the heavy lifting for us so that we as application developers can focus on product only. In a way, serverless abstracts away our worries. It doesn't give us any access to these infrastructure-related concerns, which can actually make our lives very difficult if we get them wrong. So load balancing, scaling, availability zones, these are just things you don't have to worry about using serverless. This allows you as an application developer to deliver more quickly. And also, it allows, as we previously mentioned, it allows us to work smarter, not harder. Instead of having to worry about the heavy lifting, we have more room to focus on creating value. But this is not the only power of serverless. It is fully scalable by design. Serverless functions are able to scale to run in bursts according to the events that they've received. And this is very, very powerful. Also, because they are short-lived, we only pay for what we use. This has allowed us at Cytora to deliver quickly while staying scrappy and lean and keeping costs down. Now that we understand the serverless fundamentals, it's time to step into the wonderful world of AWS. It's not good enough to run lightning-fast code that exists in isolation. We need to integrate with a wide variety of events if we are able to solve complex problems. This is where the serverless ecosystem comes into play. AWS Lambda runs serverless functions and manages messages from a wide variety of triggers, such as HTTP requests from Amazon API Gateway, messages from SQS or SNS, database updates from Amazon DynamoDB, and code changes from code commit. These are not the only events that it integrates with, but these are some that I wanted to showcase for you today. So now, to take it more from a theoretical realm into an applied realm, let's peek under the hood of Gopher Tweets. While Gopher Tweets doesn't do very much, it actually uses a wide variety of technologies. Starting from the bottom up, we have the Gopher Tweets backend, which is a Go app deployed to AWS Lambda. It is in charge of talking to the Twitter API, logging in, and posting tweets, as I've demonstrated for you. In front of the Gopher Tweets backend, we have Amazon API Gateway, which is in charge of invoking the Lambda for HTTP requests. Now, at this point, API Gateway exposes a REST endpoint, but that's not very nice to use. So we've also built a very snazzy React front end, which is hosted in S3 and is in front of Amazon API Gateway. And that's what you saw, which was like the best front end you've ever seen. And in order to speed up load times, because we're all around the world, we've actually deployed a CloudFront distribution in front of it. So this is what we'll be exploring today. And now that we've really looked into the fundamentals, it's time to look at the nitty-gritty details with serverless in action. Take it away, Xiao.
Thank you very much, Adelina. So we've just learned about serverless computing in general. Now let's dive a little deeper and look closer into how things work. And we'll explain with AWS Lambda, because we use AWS Lambda mostly at Cytora. The concept is pretty similar in Azure and the GCP. AWS Lambda is Amazon's serverless computing resource. It is on demand, so meaning that you only pay for the duration of the time that your code runs. It is fully managed, meaning that all these concerns that Adelina mentioned, you don't need to worry about them. Now let's move to the very important idea, which is Lambda handler. So Lambda handler is the entry point of your code and the interface where AWS Lambda and your code connects. It is required to be of a specific signature so that your code and AWS Lambda will be able to understand each other. In this case, the handler is usually within this signature, and all of these are optional. This brings us to the next part, which is about Lambda triggers. So when we say Lambda function trigger, we're triggering a Lambda function. We're really talking about AWS Lambda running your code in response to events. And there are many different types of events available. As Adelina mentioned, you can use these events to invoke your Lambda functions. Lambda has 3 modes of invocation, and different types of events invoke a Lambda function with a different mode. The first mode is a synchronous invocation. For example, API gateway events are invoking the Lambda functions in this synchronous mode. So for synchronous invocation, the caller is expected to wait for a response back in a relatively short period of time. So generally, these functions are short-lived. And if the execution fails or errors, it is the caller's responsibility to handle the error and retry if needed. The next mode is asynchronous invocation. For example, like things like S3 events, SNS events, they fall into this group. So for async invocation, the caller is not expecting a return. It places the event in an internal queue, where your code will process the queue. It can also send the result to a destination. The internal queue between the caller and the function is managed by AWS Lambda service. It ensures that messages are stored durably, and your function will scale automatically as the queue grows. You can configure retries and dead letter queues so that Lambda can retry your code for a configured number of times. A third type of mode is a polling invocation. It is done with event source mapping, which is an AWS Lambda resource that reads from the event source and invokes your Lambda function. The source service itself does not invoke Lambda function directly. The settings and polling behaviors vary by event source. So one of the most important event trigger is API gateway. By using API gateway as the event source, it allows you to easily create and maintain RESTful APIs. And our Gopher tweet is a combination of API gateway and Lambda functions. The next part brings us to the lifecycle of Lambda functions. So generally, a Lambda function invocation is split into 2 parts. The first part is fully managed and optimized by AWS, and the second part is managed by your code. In the first part, we call it code start, where AWS Lambda will download your code and it will start a new execution environment. The next part is within your code. The key takeaway here is that there is a code start in AWS Lambda that may or may not affect your workflow. If you think a code start might interrupt your workflow, so one way to properly do that is to use provisioned concurrency. The provisioned concurrency is what Lambda offers to help you to reduce the time both in code start and invocation. So for code start, the environment setup will be done during the provision process rather than during the execution. But in invocation, it will always keep the function initialized, thus to further reduce the time. Finally, let's talk about SAM. SAM is a CLI tool that helps you to build, test, debug, and deploy serverless applications. We use the SAM lot as Cytora throughout the whole development lifecycle. We will see how these commands work in detail later on in the following demos.
Excellent. We're basically serverless experts now. So let's have a look at actually doing some stuff, getting our hands dirty. The time has come for the greatest show, which is the live Gopher tweets change and deploy. You can find our code at github.com/Cytora Gopher tweets function, and you can have a play around with it. We can answer any questions you want later. But for now, what we're going to do is we're going to examine the code, make some changes to it, redeploy it, and really get a feel of how you interact with serverless functions. So without further ado, let's step away from these silly slides and have a look at some actual code. Now, I'm going to open Golang, And then we can have a look here. So what we really want to showcase here is the fact that serverless is not a framework that you need to write your code for. A serverless app is an app like any other. And as you can see in the main file, it's very simple. We get some config, then we set together some HTTP handlers that we use together in a mock, that we put together in a mux, since we have several endpoints in our Lambda function. And then we pass this mux to the Lambda handler. The Lambda handler is the one that Xiao was talking about during the serverless in action section. And if I click through here, we can see that it's the exact signature that Xiao presented to you. So this is how we invoke the Lambda handler with our code. Now, if we go back to the main function, let's have a look at one of these handlers. The most interesting part of functionality in Gopher tweets is the tweet handler. So let's have a look at it now. At the very top, we have a function called tweet, which is the one that's going to be invoked with an HTTP request. Because we are making CORS requests, we need to handle pre-flight requests, but those are not very interesting. So we'll have a look at what happens on the post tweet. Now, on the post tweet, we need to read from the body of the request and decode it. We do this here in the new tweet request. We decode the JSON and create a model called tweet request. Now, if we go back, we'll be able to see that once we have the post, we then invoke the Twitter client with the API key issued to us by Twitter, and then we send the constructed tweet over to the Twitter client. Now, I've got a line commented out on line 58. And basically what it does is it takes anything that you write and adds two new hashtags, hashtag serverless rocks and Gopher tweets. Let's say that I want to enforce that all tweets will go through with these two hashtags. You know, maybe I want to track how many people are using Gopher tweets. So I will now leave this in and let's have a look. So Xiao, how do I make sure that I haven't broken anything?
So we need to run that locally, right? And running code locally is very important when we do local developments. But before that, should we have a look first at the SAM template we've built?
Excellent.
So basically, the SAM template is a CloudFormation template with a SAM syntax. It's a special syntax that allows you to build your Lambda functions easier. And within here, we can see we defined a resource, which is a serverless function, and we defined all its properties as well as its triggers. By using this syntax, later CloudFormation will transform this syntax into a fully compliant CloudFormation template, and it will deploy all these functions, triggers with CloudFormation. So now let's have a look at our makefile. Here is what we make a lot of use of SAM. The first one we do is SAM build, where basically it will build an artifact from a code as well as the template. And the next one we're going to use is actually the SAM local start API. You'll read the configs from this template and mount your code into this local runtime. Thus, you will be able to have a local running API service. Should we run make start, Adelina?
Excellent. I'll open my terminal and then just type that in exactly like Xiao said. So what happens here is we've started our Lambda function on localhost 3000. As we previously mentioned, the API gateway is actually a REST API in front of our Lambda function. So we can invoke it without the use of our front end. What we're going to do is I'm going to use Postman so we can have a look at our function locally. We've exposed a health endpoint just to see that the backend is alive. So I'm going to send this down. What you will see now is that it will take a while for the response to come back. This is because we are actually running a cold start, exactly like Xiao described in his serverless in action section. Now it's time to try and test it out by posting a tweet. I've got another request here that says hello from the localhost side, and we can have a look what happens if I send this. I will now publish the tweet. As you can see, I'm sending the request, and this was actually much faster because now we have the Lambda that's been warmed up. Let's have a look on my Twitter account that we're now very accustomed to, and see if our tweet actually came through. If I refresh my Twitter account, then we can see here, hello from the local host side, and we've appended the mandatory hashtag serverless rocks and Gopher tweets. Now, Xiao, let's have a look at how do I get these changes in production?
We just push the commit to remote.
Excellent. So I'm going to commit this exactly like we're used to. Changes. Please forgive my not very well formulated commit comment. I didn't push. I'm going to push the changes, and then let's have a look at our Circle CI pipeline. I'm going to refresh the pipeline that I've already got loaded here, and look, our changes are now picked up. All right, so now the tests are passed, and Xiao can tell us more about the build and deploy phase.
So basically, we're fully utilizing this SAM CLI to help us with that. First of all, you can see we use SAM build to build the artifact for us. And then we call SAM deploy with a few param overrides. So within SAM deploy, it first of all uploads the new artifact into S3 buckets. If you're using a customer container runtime, the artifact will be uploaded to ECR. What happens next is actually it deploys a new CloudFormation template. As we mentioned, we're using the SAM syntax. CloudFormation will transform and expands that into a fully compliant CloudFormation template. And all these change sets will be deployed through CloudFormation. In Cytora, we also configure pre-traffic hooks with the code deploy in AWS, where we can run all these health checks component tests to implement a blue-green deployment. And it's only until the component test is passed, it will shift the traffic from the old Lambda function to the new Lambda function.
All right, so now that everything seems to be deployed, the only last step is to see if our changes actually made it to production. So I will go back to our Gopher tweets front end, which we know is like hooked into production, and I'll tweet at myself again, and I'll just say, this is after our code change. And we should see that the new code is invoked immediately. If I go back to my Twitter account, we'll be able to see the exact code that has happened together with the serverless rocks and Gopher tweets hashtags. So we hope that you've been thoroughly amazed, because this brings us to the end of our demo, and it's time to conclude our wonderful talk. All good things must come to an end, right? So let's have a look at our conclusions. We hope that we've really showcased today how serverless can make our lives as application developers much easier by taking care of these complicated concerns of management, scaling, etc. of serverless functions. Our demo app, Gopher Tweets, showed you how easily it is to build REST APIs together with AWS Lambda and Amazon API Gateway. These true BFFs are the key to building scalable APIs. Finally, AWS SAM helped us easily build and deploy serverless applications. Running your function locally is just a command away. All these benefits showcase the power of serverless. So are you ready to join the dark side and really start building serverless? If you are, then we leave these 3 books here with you so that you can learn more about microservices and serverless architectures in general.
Thank you very much for coming to our talk. You can find our Twitter handles on Gopher Tweet. Feel free to Gopher tweet us. Hope you all had a good time.
Thank you, everyone. It's been so great. Thanks for having us.